Let's finish up chapter 1.1. We're on page 2. Logical connectors, and, or, and truth tables. Truth tables are used to analyze a complex statement by summarizing all the possibilities and their truth values. Basically, we're trying to figure out if something is true or false. Let's work with the two propositions. And remember, propositions can be true or false. We'll let R represent the proposition, you paid your rent this month. E is the proposition, you paid your electric bill this month. We will use these two propositions to demonstrate the truth tables for not, and, or. We did not just a moment ago, and that was the negation. And I'm going to introduce two symbols as well. Instead of writing not R, we could write the symbol squiggle. It's like a similar symbol, R. Or you can write it like this, not R. I'm going to do the first one more often because it's easier to find on a keyboard. So if R is true, if I put a not in that sentence, and R was you paid your rent this month, and I put a not in there, you did not pay your rent this month, it switched from being a true statement. What's not true, it's now switched to a false statement. If you had paid your rent, but the statement was that you didn't pay your rent, that statement would then become false. And likewise, if it was false, and you put a not in there, the new statement with the not would become true. Basically, with not, the truth values reverse. And. So with and, we're going to connect two propositions. R is that you're paying your rent this month, and E is you're paying your electric bill. And this, we would have this symbol that is an upward arrow for and. And think about it in terms of what would be a lie. R is you paid your rent, and you're saying that that is true, you did pay your rent. And then E is you did pay your electric bill. And you connected those two propositions with and. I paid my rent and I paid my electric bill. Was that whole sentence a lie, or was that whole sentence a truth statement? It is true. You did both, and in fact, you had done both. Let's try the next one. You paid your rent and you paid your electric bill, but the second one was false. Could you have said, I paid my rent and my electric bill, when in fact you'd only done one of them? That would be a false statement. So think about talking to your mom. You got her on the phone, and you're saying, I paid my rent and my electric bill, but you hadn't paid your rent. That was a false premise, but you had paid your electric bill. So what would the entire thing be if you hadn't done the first, but you had done the second, and you connected it with and? It would still be a lie. With and, they both need to be true for it to be true. Okay, let's do the last one. You didn't pay your rent, and you didn't pay your electricity bill, but you said, I paid my rent and my electricity bill. The whole thing is a false statement. Two falses made it a false. Or, in English, we often mean for or to be exclusive, meaning one or the other but not both. In math, however, or is usually inclusive, one or the other or both. The thing we are including or excluding is the both option. So in this case, we're going to use the same idea of you paying your rent or your electricity bill. You paid your rent, good job, and you paid your electricity bill. You said to your mom, I paid my rent or my electricity bill. Now that's weird that you'd said it that way, but were you lying? No, that's fine. It's not a false statement. You had done one of them. In fact, you'd done both of them. Good. Next one, you paid your rent or your electricity bill. You had paid your rent, but in fact, you hadn't paid your electricity bill. Was the whole statement true? One of them was true, so the whole thing is true. The next one, you hadn't paid your rent. You did pay your electrical bill, and you said, I paid my rent or my electricity bill. Yeah, you did. You chose one of them to pay, and you did. Lastly, you had a hard month, you didn't pay your rent, and you didn't pay your electricity bill, but you said, I paid my rent or my electricity bill. So that one, in fact, was a lie. With or, one true and the whole thing's true. The only way or is false is if both of them are false. And with and, the only way it was true is if both of them were true. Now we saw with the symbol for and, it was an upward arrow. Might not be too surprising to many of you, but the symbol for or is a downward arrow. I want you to do activity 1 independently, and I will do the first one as an example. 1 plus 1 equals 2, and 2 plus 3 equals 4. 1 plus 1 equals 2 is a true statement, and practice your symbols here, and 2 plus 3 equals 4. That's a false statement. Does that make the entire thing true or false? With and, they both have to be true for it to be true. And so this is a false statement. All right, I want you to try the remaining 4 independently. Cats and lizards are mammals. And for the record, cats are mammals, but lizards aren't. Oregon is a U.S. state, or Idaho is a U.S. state, and they both are. Some people are tall and some people are short. George Bush or Elvis Presley was a U.S. president. Okay, so you're going to do that yourself. A conditional statement connects two propositions with if-then. The if part is usually a hypothesis, and the second part, the then part, is usually a conclusion. The symbol for if-then is an arrow. For instance, if it is raining, then we'll go to the mall. The if part is the hypothesis. If this thing is going to happen, then the conclusion will be that we'll do this other thing. We will go to the mall. For example, let's work with the two propositions of you get an A on the final will be R, and E will be you pass the class. So the statement would be, if you get an A on the final, then you will pass this class. So pretend I'm giving you this promise in class. So in these circumstances over here in this truth table, let's put the symbols in. R implies E. In this first one, you got an A. Good job. And you passed the class. So I'm going to write what happened, and then you passed. Did I lie to you? No, everything worked out well. The entire statement is true. The second one, you did your part. You did the if-then, so you got an A. Good job. And then you didn't pass. So was I lying to you? Was this statement here a lie? Which was, if you get an A on the final, then you will pass the class. You did the hypothesis, you did the if, you got the A, but then you didn't pass. So my promise to you was a lie. You didn't get an A. Even though it says F, it doesn't mean you got an F, you just didn't get an A. Maybe you got a B. Didn't get an A. And then what happened? You passed. Is that okay? Did I lie to you? No, I didn't. Maybe you got a B. I was allowed to pass you. I just made a promise that if you did this one thing, then you would pass. If the hypothesis isn't met, the conclusion can be whatever it wants. Last one. You didn't get an A, and you didn't pass. Is that okay? Was my statement a lie? If you get an A, then you'll pass. You didn't get an A and you didn't pass. That's fine. My promise to you wasn't a lie. So the only way for it to be a false statement is if the hypothesis is met, that you did your part, but the conclusion wasn't. If it goes true, then false. That's the only way that it's false. A lot of people have a hard time, specifically with this row right here, where you didn't get an A, but you passed anyway. So picture yourself getting a B. That reality, you should still be able to pass that class if you just got something lower than an A. Okay, I want you to do example 6 independently. I'm going to do number 1 as an example, and you'll do 2 through 4. Let's say a friend tells you, if you post that photo to Facebook, you'll lose your job.